All right. So the H plus or H3O plus is the only thing that affects pH. What's the bracket stand for, Mariana? Remember? Concentration. So the H plus concentration or H3O plus concentration are the only two things that can actually change or affect the pH. So what's H3O plus called? You need to know this. You need to know this. You got to memorize this. It's on the reference table, but you shouldn't have to look it up. Hydronium. It's a hydronium ion. It's basically the same thing as an H plus because when you put an acid in water, the water gains that proton and turns into that. So those two are basically the same thing. So if I have 1,000,000 of those, I have 1,000,000 of those. Same thing. Okay, so those are basically the same. So I'm going to show you the trick. Here's a question for you. Calculate the pH of an acid if the H plus concentration is, I'm going to give you two numbers here. 0.001 molar, 0.001 molar, so that's the concentration of H plus in solution. Okay, or I'm going to put that number in scientific notation just to make sure we're comfortable with that. Or that's the same thing as 1.0 times 10 to the negative 3. So both numbers are exactly the same. You have no idea how to calculate this. There is an equation or a formula. It's the negative log of the delta H. So if you have a scientific calculator, you take the negative log of this number, you'll get the pH. That's like the math. But you don't need to do that in Regents Chem because they don't give you squirrely numbers. In other words, it's always 0.00001 or 0.01 or 0.00. It's always 1 with a whole bunch of zeros or some zeros. So you don't have to deal with actual real numbers like 0.02567. That you can't do the little trick. I'm going to show you a trick. You need to use the equation. I'm just kind of telling you how to do it in real life, but in Regents land, here's how we do it. The pH of this solution, the answer to this question, is 3. And there's a trick. You don't need to know any math. All you have to do is be able to count or see. So if you can see, you're good. If you can count, you're good. Does anyone know where I might be getting that 3 from? Back with the zeros, right. It's the number of decimal places. 1, 2, 3. That's the pH. Or, if they give you scientific notation, it's just the exponent. How easy is that? I don't really need to teach you much more. You just need to remember that. So if they give you the H plus concentration, all you need to do is count the decimal places or put it in scientific notation, which is basically the same thing as counting decimal places, and take that exponent. It works every single time. It never doesn't work. All right? So that's a trick, and that's how we do it in Regents world here. Okay? So I'll give you another example, but I can't make it any trickier. That's how you find the pH, but they have to give you this or this, same thing. Okay? They have to give you the concentration. So I'm going to reword it, make it a little trickier. All right? But it's the same concept. Calculate the pH of a 0.1 molar HCl solution. This is a little tricky. Calculate the pH of a 0.1 molar HCl solution. So I just told you need the H plus or H3O plus concentration. I didn't give you either one. Or did I? So I'm going to explain. Who's following me here? Who's picking up what I'm putting down? Dylan is. You had a great answer for those two questions on that kinetic equilibrium sheet. I wrote that on the top. I was going to have you read it to the class, but some other time. Just want to give you props for that. A lot of you did well on that take-home quiz, but his answer was great. Anyways, back to this. I didn't give you H plus, I didn't give you H3O plus.
HCl. That's hydrogen.
Yes. What do all acids do in solution? What's that word? Starts with a D. Dissociate. Don't write this. Watch. H plus plus Cl minus That's dissociation. And let's remember, if it produces ions in solution, what can acids do? Ions. What do ions do? Conduct electricity. What's that called? Electrolyte. Electrolyte. That's an electrolyte. So just a little review there. So, if this is 0.1, guess what? That's 0.1 and that's 0.1 because this dissociates 100%. In other words, everything here is everything here. So I am giving you the H+. I'm just not going, it's just not being straightforward about it. So, if the H+ concentration, so my H+ concentration here is 0.1 molar, you could put that in scientific notation or not. You could just count the decimal places, so we could do that. 1.0 times 10 to the negative 1. Either one, the pH is 1. Because one decimal place or the exponent is 1. So the H+ concentration tells us the pH. And if the H+ concentration increases, the pH decreases. If the H+ concentration decreases, pH increases. It's opposite. Because these are numbers less than 1. If that's confusing, let me give you an example. So if we have an H+ concentration of 0.01, we have an H+ concentration of 0.001, H+ concentration 0.000001. Write all these down, please. I'm trying to put this in perspective. Maybe some of you get it quickly, maybe some don't. So I'm going to give you an example here. pH equals, pH equals, pH equals. All right, what's the pH for the first one here? Shout it out. 2. Very good. What about the next one? 3. Next one. How many? 6? 6, right. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2. Okay, this is what I was saying. As the concentration of the H+ decreases, right? This is a low concentration. This is a high concentration, right? 0.01 is a bigger number than 0.00001. That should make sense to you because acids produce H+. If there's more H+, you're going to have a more acidic solution, which is lower pH. Higher pH, less acidic, more basic. I feel like I'm going a little quick here. Questions? Stop for a second. So, if I said, don't write this, but if I had a 0.1 molar HCl versus a 0.01 molar HCl, you should be able to tell me which one is a stronger acid. Which one has a lower pH? This one. Because it's a pH of 1, that's a pH of 2. So you should be able to do that now. That's my goal here, my hope. So write the concentration out, put it in scientific notation if it helps you, whatever helps, and just count the decimal places or take the exponent, right? That's how we do it. Okay, so why am I going through this? 1, you might be asked this type of question, and 2, this helps explain why this is 10 times more acidic than that. But this is 1,000 times more acidic than this because of the decimal places. Every time you move a decimal, doesn't matter what direction, it's a factor of 10. So that explains why things are 10 times more acidic, 10 times more basic, or 100, or 1,000, because it's really based on the concentration. That's why when Cassie said you count the zeros, that's why you can do that, because of the numbers and the decimal places. All right, so I'm going to kind of rewrite what we did on the board with the homework, and then we'll move on. Something different here. Hopefully I'll talk about table M. As usual, it takes me longer than I expect. So here we go. Each unit on the pH scale changes the H+ concentration by a factor of 10. That's kind of like the book way to say it. Each unit on the pH scale changes the H plus concentration by a factor of 10. So what does that mean? Let's get an example. So this means a pH of 2 is 10 times more acidic than a pH of 3. That's what that means. Or another way we could write this, a pH of, let's say, 6 is 10 times more basic than a pH of 5. It just depends. Are we going up the scale or down the scale? So each unit, you multiply the acidity or the, that's not the right word, how basic or how acidic it is by a factor of 10. And again, the way Cassie said it, count the zeros. I like that. So that's what this means. Got that down? Yes, yes? Okay. Alright, so I could kind of ask you a combination question. I'm going to give you 2 solutions with H plus concentrations. You figure out their pH, and then I'm going to ask which one, or how many times more acidic or basic one is than the other. Okay, so write this down. You have 2 solutions. 2 solutions. Let's see here. 2 solutions. We have solution A, which has an H plus concentration of 0.0001. And we have solution B with an H plus concentration of 0.00000001. I'm being nice, I think, not putting it in scientific notation. Maybe not. Maybe that makes it harder. That's ridiculous. You will never see that number on a test or even in AP. You'll put it in scientific notation. But I'm just doing it to keep it consistent. So you have 2 solutions, A and B. Here's the 2 parts I want you to answer here. So first thing here, calculate pH of A and B. And then 2, tell me how many times more basic / acidic, bless you, whoever that was. How many times more basic or acidic, I'm not going to answer that for you. Solution B is compared to solution A. So this is kind of like taking everything we just talked about, put it in one question. So you have 2 solutions, they give you the H plus concentration. Calculate the pH of A and B. Then tell me how many times more basic or acidic B is compared to A. And again, I say basic / acidic, so I don't want to tell you the right way to word it. I want you to figure it out. So I'm just going to erase this so I have room to answer this here. Hopefully you had that. Definitely not going to get to that gizmo today, but maybe I can at least show you some indicators right here at the end. pH of A, pH of B. Oops. All right, who knows the pH of A? Shane. 4. Good. pH of B. Anybody? Laura? 9. Let's double check those. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. All right. So who can answer the second question? Max. B is 100,000 times more acidic. You said basic? Basic than A. Yes. B is more basic than A. Very good. Let's see. 4, 5, 6, 7, 8, 9. I have to do this sometimes myself, right? So we're going 1, 2, 3, 4, 5, so 0, 0, 0, 0, 0. So 100,000 times, very good. So B is 100,000 times more basic than A. Very good. All right. So before you pack up, you can, but you got to keep reference table M out. I'm just going to show you one thing. Hopefully I can get it out. You know, I always get trapped here about a belt. Here we go. So if I pour a little bit of this in the beaker, okay, so go to table M. Let's pretend you didn't know what I put in there. Maybe you don't. Okay, here we go. Aha, aha. That's boring. Let's do this one. Okay, this is bromthymol blue. Go to table M. This is bromthymol blue. Observe. Everybody see what happens there? Go to table M and tell me, what's in this beaker, an acid or a base, and how do you know? So I put bromthymol blue and it turned yellow. You go to table M, look under bromthymol blue. It'll be in suspense till tomorrow. You won't sleep tonight wondering, is that an acid or a base? I need to know.